Hi guys, welcome back to my channel. Today I'm going to explain how you can tackle integral of the form f prime of s divided by f of s. So in the last video I explained what is meant by u-substitution integral, and I told you it is very simple. What you have to do is to what? Is to make your u, for example, you can make it to be a function in the linear function of x you differentiate. Then you now make your ds the subject of the formula. So immediately you make it the subject of the formula, then you substitute all the values in terms of u into your integral, then you now integrate. So that's that. But as a consequence of this u substitution integral, I'm going to teach you two principles. The first one is when you have integral f prime of s divided by f of s dx, and when you have integral f of s multiplied by f prime of s ds. This is very simple. So let me take it one by one. The first one is when you have integral of this form. What this one is saying is that when you are given an integration and you observe that when you have a function at the denominator and you differentiate it, you now have your derivative at the numerator. So you don't need to stress yourself. Then your result will be of the form ln f of s plus c. If you don't understand what I said, take for example, if I have integral s cube plus 2s plus 4 3x squared plus 2 dx. If you check this integral very well, if you check the denominator, we have 3s cube plus 2s plus 4. If we differentiate this, derivative of s cube plus 2s plus 4 is going to give me what? 3x squared plus 2, right? So if you have this type of integral, so whereby when you differentiate the denominator and you have the derivative at the numerator, don't stress yourself. Then your result will be ln the denominator plus c. So how? I'm going to show it for you. But recall what I said, if you have your integral in terms of fraction, then before you do anything, just check whether if you differentiate it, if you differentiate the denominator, you are going to have your result at the numerator. If you have it at the numerator, then you are fine. Okay, now let us show that. It is not difficult to show. It is as a consequence of u-substitution method. Okay, solution. Suppose we want to show this. I have integral 3s squared plus 2 divided by s cubed plus 2s plus 4. Then you can make your u to be s cubed plus 2s plus 4. So to know your u here, you can just think of the one such a way that when you differentiate it, you are going to have a function in terms of the other, or you are going to have the second function directly. So you will notice that when I take u to be numerator, if my u is equal to 3s squared plus 2, so it doesn't make any impact because derivative of 3s squared plus 2 will give me 6x. You understand now? So, and that cannot cancel this out. So, but if you make your u to be 3s s cubed plus 2s plus 4, so definitely then your du ds will give me what? So 3x squared plus 2. So which is one of the, one of what we are doing in u substitution, because we are interested in what? In replacing this value by what we have together so that we can get rid of x, then we have all our integral in terms of u. Okay, now, so if you have this, then you can make your du the subject of the formula, that is 3s squared plus 2 ds, right? Then ds will be what? If you divide both sides by 3s squared plus 2, that's the u divided by 3s squared plus 2. Then you go back to your question again. I have 3s squared plus 2 s cubed plus 2s plus 4 dx, right? So then I'm going to have integral. You know, I've made my u to be, I've made 3x squared plus 2 to be u. So then I'm going to have u divided by s cube, no, sorry. My u is s cube plus 2s plus 4, not the numerator. So you have 3s squared plus 2, and I've made the numerator to be what? To be u. Then multiply by ds. What is my ds? You know, this is my ds here. You can also substitute that. Then ds will be du divided by 3s squared plus 2. Then these two guys will cancel this guy. What are you going to have left? I have 1 divided by u du. And don't forget, what is integral of 1 over u? You know, integral of 1 over s is ln x. Then integral of 1 over u will also be ln u plus c. So we substitute the value of your u, then I'm going to have s cube plus 2s plus 4 plus c. Look at it. So you will see that we had what we wrote here before. So what we predicted to have. So in essence, when you have integral of the form f prime of s divided by f of s in such a way that when you differentiate the denominator, you are going to have the numerator. Don't stress yourself. Then you are going to have what? You are going to have ln s cube plus 2s plus 4. That is the denominator plus c. Okay, let me give you another example. Example number 2, I have integral x squared x divided by tan x dx. Don't forget what I told you. Anytime you have your integral in terms of fraction, you don't need to stress yourself. Check the denominator first. Our denominator here is tan x. See whether if you differentiate the denominator, you are going to get the numerator. What is the derivative of tan x here? You know it is x squared s. We differentiated the denominator and we got the numerator. Then our result will be ln tan x plus c. It is as simple as that. Okay, let us show it. So we can also show that using u substitution, right? My u will be tan x, then you find your du dx, that is x squared x, right? So, and your dx is going to be what? Du divided by x squared s. You go back to your question, you know our u, then you have x squared x divided by, what is your u before? You know you've made u to be tan x, then this will be u multiplied by, what is my ds? That is du divided by x squared x. You know this stupid guy cancel each other. Then we have integral 1 over u divided by u. And what is integral of 1 over u? That is ln u plus c. Understand now? If you substitute there, what is your u? You know your u is tan x. Then I'm going to have ln tan x plus c. So what we predicted we are going to have, that's that. So in essence, when you have integral in form of fraction, such a way that when you differentiate the denominator, you are going to have your result at the numerator. Don't stress yourself. Your result will be ln f of s, that is the denominator, plus what? Plus c. So in the next video, I'm going to take you through the second property or second principle, which is integral f prime of x f of s dx. So if you enjoyed this video, don't forget to subscribe, click on like and share button, and invite your friends to do so. Thank you.